calculator. Okay, there's my calculator. Okay. So we're in chapter 25, doing section 2 first. In chapter 2, section 2, we're doing volumes of rotation. And so we're taking something and we're rotating it around some axes, and we're getting the volume associated with that guy. And we're going to use the disk method. So what we're doing is we have something and we make a disk of that thingy, and our dx is that little itty bitty bit there, and we're finding in that disk has a circle component because I rotated it. So we're going to go pi r squared for the area of the circle, and then we're going to go pi r squared dx for the whole thing. So that's the theory of it. And then we're going to add them all together. We're going to go from some point to some point, A to B. All right, so I turn the page and I'm on 789, and I see that the formulas are going to be volume is going to be equal to pi, that's that pi sitting right there, integral, the radius, squared, dx. And there's the radius squared, and there's dx. And I'm going to go A to B. Or I could rotate around the y-axis. So I could do something and have a curve sitting over there, and I'm rotating around the y-axis. So if I'm doing the x-axis, I go pi, integral A to B, whatever the function in x is squared, so that'd be the radius squared dx. And if I was going to go and do it around the y-axis, I'd go pi, radius A to B, function in y, squared dy. So that's the theory, and that makes this particular thing easier. Now we have some nice pictures in the book we can look at and see how that's going to work. And of course we could always subtract some volume from the middle if we had something with a hole in it. We could do that too. All right, so we have 3 problems to do. We don't have any problems to do. Well, I guess we're done there. All right, so we better assign some problems. All right, so
we didn't have any problems in the...
Well, we didn't put it in the syllabus for some reason. So obviously we should be doing 5, 10, 15, 30. How's that? And then for 5, 2, and we'll do the same thing, 5, 10, 15, 30 for 5, 3.
5, 10, 15, 30?
Yeah, 5, 10, 15, 30. And it goes up to 30. And 5, 3, it doesn't go up to 30. So we'll go 5, 10, 15, 20. Or the other guy. All right, so that's what we're going to do. So we'll look at problem number 1. No, problem number 5. Way to go. Problem number 5. And it says y is equal to x minus 1. Well, that's pretty simple. That's a straight line. X is 0. Y is 1. And I want to go about the y-axis. So I got something that I'm there. I go like this. That's 1. That's minus 1. So I want y. I want to go from x is 0. X is 0, which would be there. Y is 1. X is 0 would be some, that's y is 0. X is 0 would be straight up and down. So what I'm doing is let's see if I can go back. Okay, x is 0. X is 0 is this guy. Y is 1 is that guy. So we're rotating this guy right there about the y-axis. Okay, so we need a function in y. Okay, so we'll rewrite this equation to say x equals y plus 1. Okay, so we took our equation and rewrote it, x is equal to y plus 1. So we want pi, the integral of y plus 1 squared dy. And y is going to go between minus 1 and 1. So that's the integral we're doing. So I got y plus 1 cubed divided by 3, evaluated at minus 1 and 1. I've got pi times, I put in a 1, I get a 2. 2 cubed is 8. 8 over 3 minus a 0. So it looks like it's 8 over 3 times y, times pi. So, okay, 8 divided by 3 times pi. We'll call it 8.4. 8.4. Okay, anybody else get that answer?
I got 2 pi.
Oh, bummer. You got 2 pi?
Check and see what it says back here. 8.
Number 5.
25.2.
Yeah, 25.2, number 5.
8 pi over 3.
Yeah, 8 pi over 3. That's exactly what I have. Yeah. 8 pi over 3. So your fancy calculator
Doesn't
not
work.
only gave you the wrong answer.
It doesn't work.
Okay, so that would be fine. Okay, so we got 1 right. 1 out of 1. All right, so now we're going to do number 10. So I've got y is equal to x squared, x is equal to 2, y is equal to 0, and we're going to go about x equal 2. Okay, well, that's too much information. Okay, so there's my graph. Here's my function, y is equal to x squared. Okay, so that's that guy. When I'm at 1, I'm at 1, and when I'm at 2, I'm at 4. Okay, so that's that guy. X is equal to 2. So there's x is equal to 2. Y is equal to 0. Okay, so we're taking this guy and we're rotating around x is equal to 2 around that way. Okay, so that's what we're doing. Okay, so that's the same as rotating around y. Okay. So how are we going to do that? We want pi integral radius squared dx. Okay, that's what we want. And we have that x is equal to the square root of y. And that could be dy, it could be dy or dx. So now I look at this radius. Okay, I'm going to go from 0 to 4. 0 to 4. And it's going to be dy. And when I get to 4, my radius is 0. When I'm at 0, my radius is 2. My radius is 2 when I get to 0. Okay, so if I go four minus y. 4 4 minus the square root of y squared. What's the radius? I need an equation for the radius. Okay, it's going to be 2 when I'm at 0. Okay, so if I go 2 minus the square root of y squared. Okay, so at 0, my radius is 2, and at 4, my radius is 0. Okay, so that looks right. So I'm going to solve the equation. Goes 0 to 4, 2 minus the square root of y squared dy. So I think that's the equation I want. I'm going to call it integral 0 to 4 of 4 minus 4 square root of y plus y dy. So that's what I'm going to do manually. So it's going to be 4y minus 4 y to the 3 halves divided by 3 halves plus y squared over 2 evaluated at 0 and 4. Okay, so this turns around, so I'm going to have pi 4y minus 8y to the 3 halves divided by 3 plus y squared over 2 evaluated at 0 and 4. Okay, at 0 it all goes away, so that's good. I don't have to worry about it. I don't like that. And then at 4 I become 16 minus 864 over 3 plus 16 over 2, which is 8. Okay, so I got 16 minus 64 divided by 3 plus 8 equals, so it looks like I have 2 2/3 pi. Okay, what'd you get?
I got 8 pi.
8 pi? Huh?
Which is the same as 2 2/3.
No, 8 pi and 2 2/3 pi aren't the same.
I either got 16 pi or 8 pi, depending on which way you put it in there.
Oh,
I know
bummer.
that's,
Alright, so I'll come back up to here.
I don't know if it's true or not.
Okay, so I'm going to go the integral guy. Boom. I'm going to go 0 to 4. And I'm going to go parentheses 2 minus the square root of y. Well, we can put an x in there. It doesn't matter. X parentheses squared, boom, 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 boom. Well, it's still thinking about it.
Mine takes forever sometimes too.
Yeah, still thinking about it. Still thinking about it. Yep, that's what I got.
You got 2 2/3?
Yep, I had 2 2/3.
Okay.
2 2/3. I didn't put the pi in, so I can put the pi in now.
Yeah, I see how you put it in.
Yeah. Now, if I did not set up the problem right, then I don't have the right answer, and it's an even number, so we'll never know. So now we're going to go to 15. the price of Jeopardy doubles because now the back of the book will have an answer for us.
The only difference is that I had pi in there and you didn't.
Now let's see yours.
And I had y.
Yeah, no. See, you have y dx. See, that's the
why
problem.
it's screwing it up.
Yeah, you have a y dx, yeah.
Then you have the x in there.
So yeah, you either have to have the dy be a dy, the dx be a dy, or you need to put an x, a y where the x is. Yeah. So you mix variables. Your participles were okay, but your variables were host. Okay, so I got y squared equals x. Y is equal to 0. X is equal to 4. And I'm going to go about the x-axis. Okay, so that's what I'm going to do. So I draw a picture. Now, x is equal to y squared. So 0 is 0. When y is 1, or negative 1, I'm going to be here. When y is 2 or negative 2, I'm going to be out there at 4. Okay, so I got something that looks like this. And then I've got y is equal to 0, which is that guy right there. And then I've got an x is equal to 4, which is right here. So what we're going to do is we're rotating this guy about the x-axis. That's what we're going to do. All right, so I got pi integral 0 to 4. 0 to 4 square root of x. Now when we rotate around the x-axis, we do dx, right? X-axis dx. So square root of x squared square root of x squared dx. Oh, well, that was pretty simple. X integral 0 to 4 x dx pi x pi squared over 2 evaluated at 0 and 4. At 4 there's nothing. 2 squared is 16 divided by 2 is 8. The answer should be 8 pi. So now we'll meander into the back of the book and see if I am so lucky to have an 8 pi or 25 23, 26, 25, 2, number 15. That's 26 too, that's good. Wasn't even close, there was a natural log in it. 8 pi. Yep. So that's 2 for 2, but we're not sure about the one that wasn't in the back of the book. All right, now we're going to do number 30. And number 30 has far too many words. We're going to verify that the volume of a right cylinder cone, okay, so we look in the front of the book, nothing. Oh, so, okay, so the volume of a right cylinder cone is, okay, so the front of the book says the volume is 1/3 pi r squared h. So that's what it says. Now the issue is, what in the world is a right cylinder cone? And so we'll head for the index. So you can see a picture of a cone. Pretty sure I know what it is. CO 100, it's on page 110. 101. 101. Okay, so that's a right cylinder cone. So it's something that's a circle up here, come down like that, has an axis that way, comes up this way. Where our height is right there, and our R is right there. Okay, so that's the right cylinder cone. All right. Use the disk method to verify this, where R is the radius and of the base, and H is the height. Okay, so the issue is, what is that line? So if I knew what that line was, okay, so y is equal to mx plus b. B is 0 because I go through 0, and the slope is change in y, change in x. So the equation of this line, or the equation of that line, we'll take the equation of the line on this side, is y is equal to h over r x. And that would be a positive slope and not the negative slope on the other side. So we're going to go and do integral around the y-axis. So we're going to go 0 to h. Okay, so 0 to h of something with respect to y. So it'd be r over h y squared dy. Do I like that? Okay, I might like that. I only like it if it comes out correct. And if it doesn't, then I don't like it. Okay.
Pi in there anymore?
Oh yeah, there's a pi on the outside here. Okay, so that's what we're looking at. Now, we can't use our fancy calculators to do this. So let's see what I got. We got pi r squared h squared on the outside, integral 0 to h of y squared dy. Okay, so I got pi r squared h squared y cubed over 3 evaluated at 0 and h. Okay, at 0 it's going to be 0, so I've got pi r squared h cubed over 3h squared, which gives me 1/3 pi r squared h. Was that what we're supposed to find?
Wanted.
That's what we put. So we're done with number 30. We got number 30 right. All right, so now we're going to proceed to chapter 25, section 3, where we're going to solve things by using shells. Okay, so what we're going to do is we have some curve. We're going to find some shell that comes around, and we're going to find the volume of that shell and then add them all together. So that's what we're going to do. On the order of magnitude of difficulty, this is about twice as difficult as doing discs. And we find that we have two equations. The volume is going to be 2 pi integral from someplace to someplace else of the radius. So that there's the radius r times the height. So here's the height, h, times the thickness. So that's the plan. And so volume is going to be 2 pi integral a to b x f of x dx if we're going around the y-axis. And the volume is going to be 2 pi integral whatever the limits are y f of y dy if I'm around the x-axis, depending on how I'm rotating. Okay, so here I'm rotating around the y-axis, so I would do it dx. Okay, so remembering all that, we're going to look at number 5. Now, I hope that number 5 is the same as the number 5 we just did, and it's not. Bummer, it's a different number 5. I thought sure it'd be the same number 5, and then we could have the same answer. Y squared is equal to 2x. X is equal to 0. Y is equal to 2. About the x-axis. Well, I sure did misspell that, didn't I? Okay. I'm going to move back to the last section, and sure enough, no, I don't know that. Yeah, number 5 was a different problem. Okay. So now I gotta draw a picture. Okay, so y is equal to 2x squared. At 0 on 0. When x is 1, y is going to be, well, when x is 2. When x is 2, y is going to be plus or minus 2. Okay, and when y is 8, when x is 8. When x is 8, y is going to be, x is 8 plus or minus 4. Y is going to be plus or minus 4. So that's what I'm looking at. Okay, so I have that. X is equal to 0. It's going straight up and down there. Y is equal to 2 is going there. So what we're doing is we're taking this section here, rotating it around the x-axis. Okay, so that's what we're doing. So when we rotate around the x-axis, we go 2 pi integral. Now the x-axis is going to go 1, well, when we rotate around the x-axis, we do it dy. So we're going to go 0 to 2, and then we're going to go y. So y is the square root of 2x. No, the radius. The radius is y. The radius is x. The radius, yeah, the radius is x. The y is not 2y. The height. How high is this guy going to be? Okay, so the height is going to be 2 minus the square root of 2x. No, because when I get to 0, I'm at 0. Alright, so the height is just going to be square root of 2x. And square root of 2x. Well, first of all, we're rotating around the x-axis. Okay, so it's going to be y we're rotating around the x-axis, y of x, y squared over 2 dy. Okay, so my radius is y, and my radius is y. My height is y squared over 2. No, it's not. This is number 5. I'm doing it about the x-axis. I'm rotating this about the x-axis. The radius is x. Alright, so it's about the x-axis, which means I'm parallel to the y-axis. No, I'm parallel to the x-axis. If I'm rotating it around x, I'm parallel to the x-axis. If I'm parallel to the x-axis, I got to do it dy. Okay, so I'm doing it the right way. So y is the radius. When y is 0, the radius is 0. When y is 2, the radius is 2. That's correct. And the height is y squared over 2. So when y is 0, the height is 0. When I get to here, y squared over 2, that's correct. Okay, I like my equation. And I'm ready to solve it. 2 pi interval 0 to 2 y cubed over 2 dy. 2 pi y to the 4th over 8, evaluated at 0 and 2. 2 pi y. 2 to the 4th is 16. That's a 2. So this should be 4 pi for my final answer. Because this is number 5, we can look in the back of the book. And 2, 3, 4 pi is correct. Okay, so you get 4 pi?
Can't do it with this.
What do you mean you can't do it
Can't
with
do
that?
dy.
Yeah, you can.
How do
You just
do
make
dy?
it all x's.
Oh, you can just do it all axes?
Yeah. You just change your variable, y is equal to x, once it's set up. So if I had the integral 0 to 2 of x cubed divided by 2 equals, and I end up with 2, and then multiply it by 2 pi, and I get 4 pi.
Yeah, 4 pi.
Yeah. And I thought I could change the dy. I'll try it again. I'll go integral 0 to 2 of y cubed divided by 2. And you're right, you can't change the dy to a dx to a dy.
Yeah, that's
So
weird.
you have to put it in x, but there's no difference between putting in x or putting in y as long as you have the
As
same
long as it's all
variable.
the same variable. Okay.
Yeah. Okay. So we got lucky on 5. No, I don't think so. I think it's total skill. Number 10. Number 10. Okay, so I've got x is equal to 3y minus y cubed. I'm going to go in the y-axis,
Minus y squared.
y squared, and I'm going to go about the x-axis. So I got something that looks like this. Now, when y is 0, x is going to be 0. So that's going to be that point right there. When y is 1, okay, so when y is 1, x is going to be 2. Okay, when y is minus 1, x is going to be when y is minus 1, x is going to be minus 4. X is going to be minus 4. So I got a point there. Oh, yeah. This factors y, 3 minus y. So when y is 3, when y is 0, I'm 0, and when y is 3, I'm 0. So it's going to do something like that. I'm not sure how far it's going to come out. Okay, I don't know that right offhand. All right, so it's going to look something like that. And the y-axis is going to be this guy here. So I'm going to take this part inside and rotate it around the x-axis. Okay, so I have to know where this point is out here. And it looks like that point's at 3 when y, what was this point?
3.
3. I go through 0. 3, I go through 0. But what's the biggest point out that way? Oh boy. Maybe if I had a graphing calculator.
Can you graph it in Maple?
I can. Is that my only choice? That might be my only choice. So we'll bring up Maple. Make it so I can see what I'm graphing. File. Okay, so I got x equals 3 times y minus y squared. Okay, do I have the right equation? Yes, I do. Alright, so there's my variables, x and y. Okay. The x guy, plus or minus 5, should be okay. The y guy, plus or minus 5, should be okay. Alright, so that's what I thought. So that's what I have. But I still need to know what this point is. Hmm.
2.1.
Well, I can't guess at it.
Can't put your cursor on there and it tells you?
No,
What figures?
but a graphing calculator might. Alright, so we know we got the graph right, and we know we're getting this guy. So what we're going to do, and we're rotating around this guy, right? So what we would do is break him here and get the whole thing, and then break this part here and subtract that part away. But we have to know where that point is on the x-axis. How are we going to know that?
Does it look like the y value is 1.5?
That's it. Yes. If it's symmetrical, so if it goes through 1 and 3, which it did, then y equal 1.5 has to be what we're looking for. Excellent call. So 3 times 1.5 minus 1.5 squared. Three times 1.5 minus 1.5 squared, 2.25, 2 1/4. Okay, so that's what we're going to do. We're going around the x-axis. So parallel to the x-axis means I'm using y. Parallel to the x, no, yeah, we're parallel to the x-axis. Shells parallel to the x-axis. But how do I get that guy? I can do that, but how do I get rid of this guy? Okay. We need to write it as a function in y. How is that guy going to be a function? Okay, so I already have the function in y. Okay, so I might be there already. I'm going to go 2 pi integral 0 to 2.25. No. This is d. Okay, so I'm going to go 0 to 3. 0 to 3. The radius is y. Yes, it is. Yes, the radius is y. And the height is 3y minus y squared dy. Okay, so okay, well yeah, that looks good. So I'm doing shells. My radius is that, and my height is whatever this guy is as I'm going through. Okay, so that looks like what I've got. That looks right. All right, so I've got 2 pi integral 0 to 3y squared minus y cubed dy. 2 pi y cubed minus y to the 4th over 4 evaluated at 0 and 3. I got 2 pi, 0 is 0, so that's good. 3 cubed is 27 minus 3 to the 4th, which is 81 over 4, equals, okay, so I got 27 minus 81 over 4, 6 3/4 times 2, 13 1/2 pi. 13 1/2 pi. Alright, so we got
27 pi over 2. Same thing.
27.
Be 13.5 pi, wouldn't it?
Yeah. No, it'd be. Yeah.
Yeah.
Yeah. Yeah. All right. Oh, let me check my cell phone. What's this guy doing? I got a new message from Sprint. Well, forget them. Just because I have free texting doesn't mean I have to answer the messages. Okay, so number 15. And we can't check it with the back of the book, so that means we don't have to. 15. I've got y is x cubed. I've got y is x. I've got x is 0. X of 0, 2. X is 1. About the x-axis. Okay, so y is equal to x cubed. Looks something like this. Okay, so that's y is equal to x cubed. Y is equal to x. Looks something like that. That's y is equal to x. X is equal to 0 is that guy. X is equal to 1 is this guy. So what we're trying to do, we're trying to find this itty bitty sliver here rotating around the x-axis. Okay, so that's what we're trying to do. And rotating around going back to our formula, rotating around the x-axis means I'm parallel to the x-axis. So my volume is going to be 2 pi integral 0 to 1, because that's at 1. That's 1. 0 to 1 y. Function of y, which would be cube root of y dy. No. No, afraid not. What is the height? The radius is y. The radius is y. Okay. That's what the radius, but the height is on this side. So the height is y minus the cube root of y. So my height is only between here and here, here and here, here and here. That's how big my height is. Okay, so my radius, as I rotate around, then is going to be y, I agree. But the height is only this itty bitty bit. Okay. So I got 2 pi integral 0 to 1 y squared minus y to the 4/3 dy. 2 pi y squared over 2 minus y to the 7/3 over 7/3 y cubed over 3. 7/3 over 7/3 evaluated at 1 and 0. 2 pi 1/3 minus 3/7. Yeah, I don't think so. That's a negative number. How did I get a negative number?
You ended up getting a negative number 2.
How did I get a negative number? Cubed over 3. Seven-thirds, 4/3. So are these, is the curve the other way? No, I don't think the curve's the other way. What am I doing wrong?
The way the question was.
What's the question?
Well, it says from x equals 0 to x equals 1.
X equals 0 to x equals 1, yeah.
So would that mean x equals 1?
Yeah, that's what this is, x equals 1. So I'm going from 0 to 1. I'm taking this itty bitty bit. Oh, wait a minute. Yeah, but I'm subtracting the wrong way. That's my problem. This is the cube root of y minus y. So the biggest guy is this guy. And when I take it away, I want a positive number. So that's my problem. So let's see. So we turn each of those guys around. And that's y to the 4/3 minus y squared. And this becomes y to the 7/3 divided by 7/3 minus y cubed over 3. And this becomes 3/7 minus 1/3. Okay, so I got 3/7. 3/7 minus 1. Shit, wrong button. 3/7 minus 1/3 equals times 2 equals 0.19 pi. Okay, well, 21, right? So this would be 9 21s minus 7 21s, so it'd be 2 21s, so that'd be 4 pi over 21. All right, and this is 15, so we ought to get a 2315. 4 pi over 21 checks with backup book. Alright. So number 20, and we get to go home. Number 20. Okay, so I've got y equals x minus 2 squared, y is equal to 0 about the y-axis. Okay, so I've got y is equal to 0. We'll do him first. Okay, so there's y is equal to 0. Now this guy, when x is 0, y is going to be 4. When x is 1, y is going to be 1. Okay, when x is 2, y is going to be 0. But when x is 0, y is going to be 0. When x is 2, y is going to be 0. When x is 1, y is going to be 1. So it looks like it's something that's going to do something like this. But then it probably, when it gets here, it probably does something like that, right? Because it can't go negative. As x gets bigger, it can't go negative. Okay, so back to Maple. So I'm looking at y equals x times x minus 2 squared. Well, talk about fat fingering keys. Minus 2. Didn't get the minus sign right. Didn't get the 2 right. Okay, we're going to bring the parameters out a little bit. What do you think? Plus or minus 10? Maybe. Would be better. Yeah, that's what I thought. So it does something like that. All right, so we're only looking at, oh, yeah, but it passes. We know it's going to pass through 0. So just because it doesn't mean it didn't. They're just doing straight lines every 1/2 to do their thing. Okay, so that's what we're looking at. Something that looks like that. And we're rotating about the y-axis, so we're going to go that way around the y-axis. Okay, so picture's right. When I rotate around the y-axis, I'm going to go, volume is 2 pi integral. I'm going to go from 1 to 2, 0 to 2, 0 to 2, 0 to 2, x, the function of x, so that'd be x minus 2 squared dx. parallel to the y-axis. Parallel to the y-axis means I'm rotating around. Okay, so that's what I'm doing. So x is the radius, I agree. X minus 2x squared is the height, I agree. Okay, so that's the integral we're solving. V is equal to 2 pi integral 0 to 2. I've got x to the 4th minus 4x cubed plus 4x squared dx. Okay, so I got 2 pi x to the 5th over 5 x to the 4th minus 4x cubed over 3 evaluated at 0 and 2. 2 pi 32 over 5 minus 16 minus plus. That's good. It's good that that's plus 2. 2 cubed, that's 8 times 4. 32. 32 over 3. Okay, so I got 32 over 5 minus 16 plus 32 over 3 equals. That looks like 2 pi times 1 and 1/12 is what it looks like. No, it's not 1 and 1/12. Is it 1/15? 1 divided by 15. Yeah, 1/15. So that'd be 16/15ths. So that'd be 32/15ths pi. And we don't have 32/15ths pi. Yeah. Excellent. So that's a check by calculator. And we are done. So, if you ever find yourself in a position where you think you have to work these types of problems, clearly you should think again, right?
Did you know this button right here?
That button? Oh,
Yeah.
what does that do?
Makes you go back to
That's the fraction.
Yeah.
That's the fraction,
fraction
decimal button.
Yeah.
So I didn't have to figure it out myself. Syntax. Well, anyway,
to. Yeah, you just push it once and
cool.
you're in there.
So I got 1 divided by 15. I have that and hit this button. Boom, 1/15. Cool. Push it again. Boom, goes the other way. Push it again. Well, this is fun.
Yeah.
I did not know where that button was. Okay, Control Alt